So you can tell these guys have a different way of looking at things. Casey has such a unique perspective. Will you share it with us?
No, I'd love to. So, if I take off my prosthesis and you ask me to walk across the stage, I couldn't. And it's very accurate to say that I'm disabled at that point. I put the leg back on, and as you can see, I can move as well as the next guy. And I'm completely able, but different. And the goal with what we do is I don't want to be just abled, I want to be super enabled.
We look at the space in Casey's leg was as an opportunity to enhance his life.
And it's a terrific way of looking at things. So we've seen a little bit of what you do. Tell us about the process and how you got into this.
Well, our process is I'll have a need, or another amputee will come to me with something that they want to do. And I take that in and I think about what is the most outrageous thing we can do to make that possible for that person. And then I take that to Bill.
Casey's ideas are kind of crazy sometimes, and I have to filter that a little bit. I always start with the constraints, how much time we have, what's it going to cost, is it real, is it possible? And we kind of, kick some ideas around. Sometimes it's going in one tangent, sometimes it comes back in the center, we have a really good idea. I always try and look at those elements from a realistic standpoint. Casey's got a really amazing mind, and sometimes he's not based in reality, but pretty good. But nothing's impossible. It's always going to be something incredible. We spitball ideas, we kick stuff back and forth, and we focus on the strongest and the weakest points. And somewhere we have a product.
Right, and we keep it fun when we put these ideas together.
Right, and that's the important thing. We've seen quite a bit of projects, but why don't you walk us through one of your first ones? I think it was had to do with your love of skin diving.
Right, I'm an avid free diver, and when I first started diving after I lost my leg, I would only use one fin just to have the freedom. And I got to be a pretty good diver, and I was able to hold my breath for an extraordinarily long time, and I was going deeper and deeper and finding that I was getting into trouble kicking back up. So I went to Bill for our very first project, and I said, how can we attach a fin to my leg that would give me enough power to kick up from a dive that is upwards of 100 feet?
In my company, we do urethane, polyurethane. We were already making a force fin, and we do a lot of prototypes. So Casey's got the socket with a fitting, the standard pyramid fitting that this prosthesis is attached to. And it's pretty solid. So the simplest thing was to take that as a starting point, and then just attach a fin to it, and let him swim away and see how it worked. But in doing so, we found there were a few issues we had to deal with, and that is, how does he get in and out of the water? And the simplest was to put a peg leg on it, and let him hobble down, hold the fin out of the way, simple hinge unit, it locks down, great, unhinge it, and he's able to have access. There was another problem that we encountered, though, and that's the socket problem.
Right, and what we found was that I was really able to get just the same amount of force out of this as I was out of my other leg. But when I was kicking, I would start to get water filtering into my prosthetic socket. And so we needed to figure out a way to make sure that that didn't happen. And also, a big fear of mine was to actually be on a dive in open water and have the leg come off and I lose it. So we came up with a retainer on a wetsuit that actually would lock around the bottom of the right there. Locks around the bottom of my socket. I put the wetsuit on, and the only way to get the leg off is to tear the wetsuit.
Right. So it's interesting. What's interesting on this project is each challenge presented a new obstacle, and with innovation, you just kept building and building until you had a great product. What we saw from the clip, that there was a motorized version, and I think that's really an interesting story. How did that come about?
Well, one of my favorite projects. I mean, this was, my vision when I first thought about building a diving leg. But ex-Navy diver came to us, and he kind of wanted to get back in the water with his friends, who were all Navy divers. And he lost his leg in a motorcycle wreck in 1997. And so I went to Bill, and I'm like, I'd really like to take him to somewhere that we haven't gone before. And so I said, can we make this motorized propeller leg that we've been talking about?
So the idea here was, use what's available. We took a standard electric trolling motor, low trolling motor, and we had an old C-scooter, Sea-Doo scooter, and married the components together, the propeller, the shroud from the C-scooter, the electric motor, and then put a pyramid fitting on the top of it, so Casey just puts this on his leg, and it's a pretty nice little motor unit. The problem we encountered after that was, how do you power this thing? So we played with a bunch of different ideas. We put a battery pack on, and motorcycle batteries in the back, and then we didn't like that because we want to scuba dive, you can't have a tank and a battery pack on your back. So we designed a weight belt that was canisters of batteries, watertight, all connected together, and a little quick disconnect switch here so that if anything goes wrong and it gets wrapped in the propeller, you can instantly just stop it because it could be a problem. And that started to make it work. All these things were done, SolidWorks, 3D printer, made a model, cast the part off that model, did a little machining, make it watertight O-ring seal, and it worked. I mean, it's such a simple process. It integrates really well.
And we have a clip of the results to show.
I hit the switch. And this thing starts to push me. And I'm going faster and faster. I'm thinking to myself, this is incredible.
We were all worried for nothing.
I'm a trained Navy diver with 2 intact legs, and I couldn't even keep up with them.
It was our design and our engineering, but it was great. We brought this to life.
And that was your friend using the prototype, is that right?
Right, yeah, he's a friend of mine now. I actually met him after he lost his leg and I talked to him about what is possible in his life.
Right, that's true. And then, as you can see, the passion went out of the water to another pastime of Casey's, which is rock climbing. And you had some challenges there as well.
Right, well, I began rock climbing after I lost my leg. And I simply just went out and bought a pair of rock climbing shoes and wore them on my prosthetic foot. And I quickly found that the leverage and just the way that the prosthetic foot worked was going to limit how well I was going to be able to climb. So I went to Bill once again, and I'm like, hey Bill, how can we make an extreme rock climbing foot?
I never did rock climbing, so I talked to Casey about it and tried to understand what was needed. So we started by going to the best climbing shoes available and kind of reverse engineering, looking at what works in these shoes. And they have very specific front edge shapes, and they also have very interesting material. It's a rubber that's really soft and grippy, but still pretty tough. And so we took that and said, okay, now how do we make this work for Casey? Because normally we take a rock climbing shoe, put it on a prosthetic foot, and try and climb, and just the interface, the connections are kind of, you start adding things like that, and it doesn't really work for him. And so we wanted to make it stronger and more solid. And part of that is that the material that the shoe's made out of, the gripping on the rock and has to be, when it slides down, as tear off or wear off. And I have a background in urethane, and so I took urethane and formulated it. The nice thing about urethane is it's an engineering material, and in SolidWorks, when you click on materials for your design, and you say urethane or something, it has tensile strength and other things that are important. But urethane can be tailored to suit very specific applications. You can make it high rebound, you can control tensile strength, elongation. And here I have 2 urethane balls, similar material, same size, same weight, and by tailoring the engineering properties, I can make one bounce and one not just by changing the chemistry. And so we use that to make a grippy material for the shoe. It's, not going to slip off the rock face when it's wet, when it's dry, cold or hot, and not wear out.